Alright guys, so I'm going to be checking out Futurology, how to terraform Mars. And the reason why I want to check out this video actually because I'm actually researching about this topic, because actually I am starting to write a book. It's called Mission to Mars and Beyond, Perspectives on Science, History, Discovery, and Destiny. And currently I'm working on a chapter about, how we went to the moon. Basically, we didn't go to the moon just because it was for discovery. No, we went to the moon because of what was going on in the world, like going against the Soviet Union, and it was during the Cold War. And then eventually, as time went on, everything went better, and the Cold War ended in 1991. And we're having talks about potentially going back to the moon and eventually colonizing Mars. So yeah, basically I'm going to be writing a different chapter in that book basically on that topic itself. So terraforming Mars and colonization, but also the possible rebuilding of Mars's magnetic field. So I'm going to kind of just talk about this video as well as the video goes on. But yeah, subscribe to Futurology if you guys are new, and basically I'm going to put the link in the description down below. So let's get started. Also give this video a like and subscribe to the channel. Also comment down below, would you ever terraform Mars, or would you even live on Mars?
Mars can be terraformed into an Earth-like paradise. Billions of years ago, Mars had a magnetic field and an atmosphere of similar density to Earth's today. Its temperature was above freezing, and it contained massive amounts.
And I think early Mars, the atmosphere was actually around a bar, near similar to Earth's atmospheric pressure.
Of surface water, which formed an ocean covering the planet's northern hemisphere.
So basically most of the northern hemisphere actually gets much lower than its southern hemisphere, because actually billions of years ago a Pluto-sized object smashed into the northern hemisphere of Mars and made the Borealis Basin. And this is what the ocean looked like. Basically filled up the Borealis Basin that we see on Mars today.
There was a climate and maybe even life. However, around 4 billion years ago, the convection in Mars' iron core, which generated its magnetic field, shut down. With no magnetic field deflecting charged particles, Mars' atmosphere was all of a sudden exposed to the solar wind.
Basically, the sun was very active at that point. It was much dimmer, but it was a very active start because it was so young. Venus had a similar story, but actually ended up the opposite, where instead of getting colder due to the sun, basically it got hotter because of its own environment. It's called the runaway greenhouse effect.
Several billion years, solar wind particles slowly stripped Mars' atmosphere. With no insulation, temperatures plunged. All water either froze or slowly escaped through the atmosphere.
A little bit of both. So yeah, basically its atmosphere and all the water that evaporated through all went away with it into space, and then this is all the stuff that came after was due to traces of volcanism that spread iron deposits, and whatever little water it had left and whatever little atmosphere it had left contained a little bit of oxygen, where the planet started to rust. So it was exposed to the harmful UV rays, but whatever oxygen it had in its atmosphere and what little water it had rusted.
Because of this, we are now left with the Mars of today, a freezing, dusty wasteland. However, it is possible to terraform Mars back into a habitable planet. With this comes many obstacles. The first is re-establishing a magnetic field to protect Mars. Several ideas have been introduced to fix this problem. The most promising is probably the magnetic shield concept. Between the Sun and Mars, there is a special point called Lagrange point 1, where the gravitational attraction between the Sun and Mars cancels out. Therefore, anything that is put there will stay in equilibrium between the two bodies. By placing an inflatable magnetic dipole with a field strength of 1 to 2 Tesla at this point, we would...
Alright, so if you guys don't know what Tesla is, no, it's not the car. Tesla is a unit of measurement to basically to test the strength of a magnet. I'm gonna look up the definition of it. I think I'm right. Alright. So a Tesla is a unit of measurement how strong a magnet is. I am correct about that. Yes.
Create a magnetic field that would deflect solar wind particles far enough to shield the entirety of Mars. By simply adding this shield, researchers have predicted that a greenhouse effect would begin on Mars. Over millions of years, this would increase the planet's temperature by about 7 degrees Celsius, facilitating the melting of Mars' polar ice. Eventually, 1/7 of the planet's former oceans would be restored. While protecting Mars from the solar wind would be a huge feat, we could do much more to speed up the terraforming process. Currently, Mars has an atmospheric pressure of around...
But there is also another possibility where you can actually restart the core, basically getting it hot enough. So, and basically how to get it hot enough is nuclear bombs. So nuclear bombing the crap out of the core, regenerating enough heat, and then eventually kick-starting the core and setting up the electrical current.
0.006 bars, compared to Earth's 1 bar at sea level. Many ideas have been proposed to thicken it. Mars has 2 polar ice caps composed of both water ice and frozen carbon dioxide, or dry ice. If we release large amounts of short-lived but extremely powerful greenhouse gases, such as chlorofluorocarbons, this would lead to a temporary greenhouse effect. The heating from this would turn some of the polar ice caps into gas. This gas would add to the greenhouse effect, raising temperatures and causing more ice to become gas. Eventually, all of the ice would turn into atmosphere, doubling the planet's atmosphere.
Also, I've heard lasers. Basically, you have thousands of strong mirrors facing the sun and collect a lot of energy.
Pressure. This process would require around 39 million tons of chlorofluorocarbons, 3 times the amount produced on Earth between 1972 and 1992. This amount could be produced on Mars in nuclear-powered factories with local materials. In addition to vaporizing ice caps, if Mars' regolith was heated, the CO2 attached to it would eventually be released. This would add about 0.04 bars of pressure, a major increase. Lastly, shallow carbon-bearing minerals and ice clathrates could be mined and heated, releasing another 0.017 bars of pressure. With all these methods, Mars' atmosphere could be heated enough to allow for the presence of liquid water. There would be weather and a global ocean covering the northern hemisphere.
But you have to deal with the lower gravity too, because a smaller planet can retain that much water on its surface. Because if it's a weaker gravity, then a smaller planet won't hold that much water.
Although Mars would be far from habitable.
Release just a little bits of water, like a shallower ocean.
All this would increase the pressure to only 6.9% of Earth. To raise this level, it's been hypothesized that carbon-bearing minerals deep in the crust could be mined and heated. This could raise pressure levels up to 1 bar. However, currently, the quantity of these minerals is unknown, and this process would be incredibly difficult. Another solution is diverting ammonia-rich comets in the outer solar system to collide with Mars. This ammonia would quickly break down into hydrogen and nitrogen, thickening the atmosphere. Lastly, we could import hydrocarbons or carbon dioxide from Earth, Venus, or Saturn's moon Titan. These combined
missions to Titan, Because Titan actually what Earth used to look like in the past when it was a frozen snowball. And Titan has a lot of carbon, chlorofluorocarbons that are very similar to what Earth has. And yeah, I mean, it's Earth's twin from the past.
Sources could get Mars' atmosphere up to 1
And
bar.
Titan's not water lakes, it's methane and ethane lakes, but it does look like Earth's lakes.
People would be able to walk on Mars' surface with no pressure suit and would only need a mask providing breathable air. But this is not enough. We want a breathable atmosphere. At this point, Mars' atmosphere would be primarily carbon dioxide. However, for humans, breathing any atmosphere over 1% carbon dioxide would cause drowsiness, and anything over 10% would likely mean death. To reduce the concentration of carbon dioxide while increasing oxygen, Mars will go green. Right now, Martian soil has about a 0.5% concentration of perchlorate, which is toxic to humans.
Perchlorate actually causes thyroid cancer.
In fact, it will provide a major health threat for early astronauts. However, some bacteria naturally consume perchlorate. These bacteria, combined with filtering systems, can eliminate the toxic chemical. Meanwhile, we can release microbes and mosses around the planet. These will spread, making healthy soil while turning carbon dioxide into oxygen. During this time, ozone will also be mass-produced to establish an artificial ozone layer. Slowly.
So yeah, basically just plant trees, plant potatoes, plant carrots. Literally just have a Martian forestry of crops to basically start photosynthesizing and then make oxygen, and then as oxygen meets the sun's rays, it makes O3, it makes ozone.
Larger plants will be incorporated.
So you basically just need 21% oxygen now and 78% nitrogen.
The environment. Fertilizer will help lighten and enrich the soil. However, due to the relatively low light levels on Mars, only certain plants will be able to survive. Gradually, Martian forests, grasslands, coral reefs, and other habitats will develop. Farmland will be established, growing food for humanity's expanding interplanetary population. And finally, after adjusting it to perfection, the Martian atmosphere will be breathable. Over millions of years, due to Mars' small size and therefore minimal escape velocity, some of this atmosphere will
that's what I was talking about. A smaller planet can't hold all of this. And most of all, some of this, it's very slow, but it takes tens of millions of years for all of this to escape into space because it's a smaller planet.
Slowly escape. However, occasional resource imports will manage this. With everything in place, animals will be released into the wild, and millions will emigrate to the planet. Still though, life on terraformed Mars would be very different from Earth. The gravity would be only 38% of Earth's, which local populations would have to adjust to. In addition, each Martian day...
So basically on Mars, if you weigh, let's say 160 pounds, you would basically weigh 38 pounds. You weigh 38 pounds on Mars.
Would be 24 hours and 37 minutes long, and each year would be 687 days long. Also, there would be a lot less light than Earth, and with no major moon, there would be no tides. Since Mars has a similar tilt to Earth, there would still be seasons. However, because Mars has a much more elliptical orbit around the Sun, these seasons would be much more erratic. With no mountain chains and almost all the water in one hemisphere, the planet's climate would be very different from Earth's. Furthermore, a lack of plate tectonics would mean no recycling of carbon, water, or land over millions of years. On the positive side though, there would be no earthquakes, volcanoes, or tsunamis. However, there would likely still be huge dust storms.
Yeah, dust storms, unless we find ways to control the Martian dust storms, just kind of alter the climate system so it doesn't affect human civilization.
Lastly, the livable area would be much smaller than Earth's. Mars has only 28% of Earth's surface area. In review, terraforming Mars is certainly possible. However, it would take hundreds or even thousands of years and would require...
Yeah, depends on, because it depends on basically on the humans. I mean, it takes thousands of years. It's probably not my lifetime. When we start to terraform Mars, I mean, maybe it might be in my lifetime, maybe not. I'm not sure.
Technology and mega projects beyond humanity's current capabilities. Right now, we should just focus on protecting Earth. What do you think? Will humanity eventually terraform Mars? Let's talk about it in the comments below.
If you and thing though, there's always people that are around saying, "How come we're spending money up there, and why we're not spending money fixing down here?" Actually, we are actually doing both. The reason why we go to space and all this stuff and terraform other planets, look at life on other planets, actually is because we study all these planets to basically compare to Earth and how to fix stuff on Earth. We basically just do both.
Enjoyed this video? It would be amazing if you like and subscribe for more videos very similar to this one. Thanks for watching, and see you next time.
Alright, so that's a very good video and kind of a pretty okay research, kind of giving a little bit of background to write the book. I'm going to look at some other documentaries and kind of get some more broader detail. But I kind of want to do a video a bit like this because it's pretty simple. It's a good way to look at our near future and humanity's future as we start talking about eventually going to Mars by the year 2050, because it's literally just around the corner. It's like 24 years. So yeah, basically thank you guys so much for watching. I'll see you guys in the next video. Bye.